Okay, so the main idea of 10.3 is that if arc RS is congruent to arc TV, then RS is congruent to TV. So if the outside arcs are congruent, then the inside chords are congruent. That's the big idea. So if we look at this example right here, I know that these two outside arcs are congruent, so these two chords are congruent. So if it asks me to solve for x, then I just have to set, these equal to each other and solve. So this lesson should be a little bit easier because you have to remember we're going back. So it's 10.3. So we haven't gotten to 10.6 yet. So it should be, don't overthink it. Think back to before you know everything you know. So if you look at example 1, I know that SR and ST are congruent, which means that this and this are congruent. Well, how many degrees is this circle? 360, and how many degrees are already taken up? So what's 360 minus 64? 296. So what I've done is I have this circle, and I subtracted 64. So I have 296 degrees left. But I have to split it evenly between how many pieces? 2. So this whole thing that's left from here to here is 296. But when I divide it, I know that each piece is 148. So x is equal to 148. Okay, over here, I know that this arc is 106. Well, let's back up. I know this chord is even with this chord. They're congruent. So if this arc is 116, then DE is how long? 116 degrees. And my center is in the middle of the circle. It's in the middle. So the outside and the inside angles are the same. Okay, let's make sure we emphasize that. If the center is in the middle of the circle, it's in the middle, then the outside arc and the inside arc are the same because it's in the very middle. So if this outside arc is 116, your x is also 116 degrees. I know 3 looks a little weird. When I went to copy this, it messed up. So pretend that's a straight line and that this arc is also a straight arc. So I know that this chord's 4 and this chord is 4. So if this arc's 82, x is also 82. 4 is very similar to 1. The whole thing is, well, I know these two are congruent. Therefore, these arcs are congruent. 90 is taken up, so I have how many left for the whole thing? 270, split evenly between 2 pieces. So 135. Okay. 5, I know the 2 arcs are congruent, so these 2 chords are congruent. So to solve, I just set them equal to each other. 2x plus 4 equals 18. So solve for x. Same for 6. What y'all get for x on 5? I got 7, yeah. Minus 14. 14 divided by 2 is 7. That's okay. Okay, for 6, I know the 2 outside arcs are congruent, so to solve for x, I can set these equal. And I know I'm solving for x because the instructions right here. It said find the value of x for each one. Did y'all get it 2? Good. Try 7, 8, and 9. 7, I know the inside chords are congruent, so are the arcs. I got x is equal to 2. 8 and 9 are set up just a little bit differently, but it's not meant to confuse you. It's saying that circle M is similar to circle P. So that means that these are the same. So we can just set those equal to each other. X is equal to 6. And then same for over here. Now you see how they're trying to throw these numbers off to confuse you? It's just backwards. So 360 minus 162 is 198. They're just trying to confuse you. So to find x, set these equal and 3x. X is equal to 13. All right, once you're done, let's flip to the back. Next piece of lesson 3 is dealing with diameters and chords. So if there's a chord, like chord AB, and there's a diameter, for example, WZ, then AX is congruent to XB. So in a circle, if a diameter is perpendicular to a chord, so it makes what kind of angle? Right angle. Then it bisects the chord and the arc. Bisects means it cuts it in half. So this is congruent to this, and then this is also congruent to this. Same for down here. RZ congruent to ZS. So if it's 90 degrees, it is perpendicular. The perpendicular bisector of a chord is the diameter. So W to Z is the diameter. What would W to O be? Radius. In a circle, two chords are congruent if and only if they are equidistant from the center. Equidistance means the same measure from the center. So WZ is perpendicular to AB. We already went over that. OX is equal to OY. So if those are the same, then AB, the chords are congruent. So because this is the same distance as this, then the chords are congruent. The big point about this that it's not saying that you're going to have to use any place where you have the center of your circle. Anywhere I draw to the outside, what's that called? Anywhere you draw it. You might have to draw your own radius to solve some of these problems. But it has to go from the center to the outside. That's the big idea. Okay, in this example, they're finding Pythagorean theorem. They said that CD is perpendicular to OE. Therefore, OD is 15, which is the radius, and CD is 24. But I know it's perpendicular, so it bisects it. So if CD is 24, this ED is just 12. So if it wants us to find OE, that's a right triangle. You can use Pythagorean theorem. Okay, let's look down here at these exercises. In circle P, the radius is 13. So what's the only radius we see? QP. Is RT a radius? No. Okay, so the only thing I know about the radius is that QP is 13, RS is 24, but there's a perpendicular bisector right here. So if RS is 24, then RP is 12, and so is this right here. Those are 12. Okay, well, it just asked us what is RT. We just solved that. RT is 12. Here is where it kind of gets a little bit tricky. It wants us to find PT. Do I know PT? No. But can I draw a radius from P to R? Do I know what the radius is? How many degrees, or how many, what are we talking about? It's 13, right? So if I draw a radius right here, from P to R, I went from the center to R, so that's a radius. And the radius is how many units? 13. So now, if I know that's 90, so can I find TP? What's your hypotenuse? 13. So what's TP? 5. Well, how long was TQ? Right, because QP is 13. So from Q to P, this whole thing was 13. But I know from T to P was 5. So from here to here is just 8. All right, and the next one, diameter is 12. What's the diameter? B to E. So that means A to B is how long? 6. And A, so B to A is 6 and A to E is 6. C to D is 8, but it bisects it, so each one of those is 4. And then the measure of arc CD is 90. So if I know that, do I need that? Yes, I think I do. So if I'm talking about this arc, the center is in the middle, okay? So from here to here is 90, so what's C to E? 45, and E to D is also 45. So one of the questions says, what is the measure of D to E? Well, we just answered it, 45. It wants us to find FD. Well, don't I know that, I'm going to redraw this. Okay, this is the center of my triangle. Here's F. I need more room. Here's F. Here's D. And here's a line. Don't I know that this is 90 degrees right here? Or this right here is 90? Do I know FD? It's 4. If I draw a radius from the center... Oh, okay. I just answered my own question. Sorry. FD's 4. Now, I'm trying to find AF. So if here's A and here's F, I'm trying to find this little piece right here. Well, FD is 4. Draw a hypotenuse. Not a hypotenuse, but also a radius. How many units is your radius? 6. So we have a triangle that has 4 and 6, and I'm trying to find this piece right here. What? Yeah, 4.47, just because it says round to the 100, or 4.5. All right, let's look at 7. In circle R, TS is 21, and U to V is 3x. So what is x? Yes, ma'am.
Do you have Emma in her?
Yes, ma'am.
Ask her to go see Miss Billings in her office, please.
Okay.
505.
Okay. TS is 21, and UV is 3x. Okay, well, I know that this radius that's coming right here shows me that this is a 90-degree triangle. This radius, if I were to draw it, that's a 90-degree angle. So, can I assume that TS and UV are congruent? Yeah.
I also need to send Kaylee McCarthy to Miss Billings as well.
Okay. Okay, let's come back to 13 and 14 tomorrow. What I want y'all to do right now, because we don't have that much longer, is I want you to finish 1 through 12 on 10.3. So what you're doing right now is 1 through 12 on 10.3. And we'll look at 13 and 14 tomorrow. Who's in charge of lesson 3?
Jenkins, I also need Cameron McCord to go to Miss Billings' office.
Okay. I'll do tomorrow. So go ahead and start on the first 2, and then we'll talk about the last 2. Those bottom 2 on 13 and 14, don't overthink it. So we're just setting, I know I told you not to do it, but it's the same 2 that are on the notes. Try 13 and 14 if you can. Don't overthink it. Let's find X. Yeah. Well, aren't they going to be the same? But it's talking about the middle. It's talking about this angle. But if it's in the center, so that's 67. So this arc, 67, this is the middle, so that arc, 67, this is 3. This is in the middle. But if it's back here, and you had to find the angle, you would have to divide it by 2. What y'all get for 1? 79, 2, 5, 3, 4, 4, 161, 5, 123, 6, 67. Good, I'm going to stop there for a minute. That's it. You never knew you could learn so much about circles, did you? You're like, I just want to know that a circle is a beach ball, that I can throw it in the pool, that's all it is. Which one do you want to know? I just didn't want to get ahead of y'all. Which one do you want to know? 11, I got 16. Yes.
What numbers did you use for 11 and 12?
On the notes or the homework?
The homework, like, for them.
Okay, so the radius is 34. So I drew a line from Y to A radius, and called it 34. So draw a radius from Y to A, and that's 34. And then we know AB is 60, so AC, or AD is half of that, which is 30. Okay, so did you draw a radius from Y to A? 14? I got 4 and 5. Alright, we'll do our checkpoint tomorrow and then start 10.5. You finished? 25? Yes, ma'am.